We will discuss about memory grant improvements in latest version of SQL Server. I'm going to use database AdventureWorks TW for this demo. I'll be creating a table called table1 underscore temp, and this table basically gets its data from an underlying table called table1. I'll be using select star into, and I'll be adding an extra column for the data as far as table1 underscore temp is concerned, which is column 5. And I'll be adding a primary key constraint on column 1 of table1 underscore temp. I'll be creating a second table called table2 underscore temp, and this table basically gets its data from a table called table1. I'll be creating a primary key constraint on column 1 of table2 underscore temp. As far as the memory grant is concerned, we use memory grants for sort operation, and when you have hashing operation, all these things uses the workspace memory. And specifically for sort, what happens is like if we have good amount of memory allocated for that particular query, then what happens is like the sort will be able to complete all its work within the allocated memory. So let's consider like the allocated memory is not sufficient for the sorts to complete it in memory. Then what happens is like whatever memory is allowed, it is basically will be performing the sort on the memory, and then everything else will basically be spilling to TempDB. And when sort spills to TempDB, the performance will be comparably worse when the same thing happens on the memory. So for this query, what I'll do is like I will execute this particular query, and this query basically selects column 1, column 2, and column 5 from table1 underscore temp. We'll be joining table1 underscore temp and table2 underscore temp, and the join condition would be table1 underscore temp dot column 1 equal to table2 underscore temp dot column 1, and then the predicate would be table1 underscore temp dot column 3 is greater than 0, and then we'll be ordering the entire result set using table1 underscore temp dot column 5. So let's include the execution plan and then execute this query. So once this query completes, we will look at the execution plan. So what I'm seeing here is like this query took close to 5 seconds to complete, and then it returned close to 118,890 rows. So that's what we are seeing right now. Now, if you look at the execution plan here, what I'm able to see is like we have a cluster index scan for table2 underscore temp, and then a cluster index scan on table1 underscore temp. We have the parallelism operator, and then the data that is coming from each of these index scan, cluster index scan. We are joining that using the hash match. And if you look at the scans here, what I'm able to see is like we are basically estimating the whole table, which is close to 118,890. We are reading that much number of rows, like the actual number of rows for all execution is 118,890, and the actual number of rows read is also 118,890. So it's a complete scan as far as the table is concerned. And now if we look at the table1 underscore temp cluster index scan, this is having the same behavior. We are estimating 118,890 rows. We are reading 118,890 and then returning the same thing. Now the hash match basically joins the information, and then we have a sort operation. Now if you look at the sort operation, what I'm able to see is like there is a warning that basically tells that operator use TempDB to spill data during execution with spill level 1 and 8 spill threads. So that means like 8 threads basically spilled to TempDB, and sort wrote 23,786 pages to and read 23,786 pages from TempDB with granted memory of 155 158,968 KB and used memory of 155,792 KB. So this is what it is. It is basically like the amount of memory allocated for sort is not sufficient. So 8 threads had to spill to 10 dB. So now what we'll do is like we will check this uh, cluster index scan further. Here what I'm seeing is like if we are able to see here, actual number of rows read is we are using 8 threads, and the actual number of rows for all execution, it basically tells like we process this many rows on each of these threads. Now, if we look at the sort operator, what you're able to see is like the actual number of rows for all execution is basically this much, and what we are able to see is like we have 8 threads, and all the 8 threads basically spilled to GemDB. If you see here, it basically tells like 8 spilled threads. So that means like the memory was not sufficient at all, and then we basically had to spill. And what I'm seeing is like the memory grant here is like basically 199 MB for this particular query. Optimizer basically allocated close to 199 MB, and what happened is like the sort basically spilled to 10 TB. If, for example, if it is going to be a previous version of SQL Server like SQL Server 2016 or SQL Server 2014, what happens is like we will have to perform certain things to balloon up this memory. For example, use some hints, and then maybe like convert one of the data type to an bigger data type. For example, like use a convert in the query. Even though it is going to have its own side effect, there is a possibility we can increase it. And also like the default resource or workload can be increased, but that's going to be a little risky. Wherein if you change the default 25%, that's going to have an overall problem. But starting 2017 and right now we are working on SQL Server 2022. What will happen is like there is no requirement to change anything. So right now what I'm seeing is like the first execution basically the sort spill to 10 dB. SQL Server is basically intelligent enough to understand like sort basically spill to 10 dB, and let's execute this query one more time. So if we execute this query one more time, let's look at the execution plan. And what I'm seeing now is like the sort is not spilling to 10 dB. Now it is the same rows that is estimated, it is read and then returned. If you look at the hash match, it is all same. But if you look at the sort operator, we don't see that. So what happens is like it's a self healing technique wherein SQL Server understands that there is a spill happening on that particular query. It understands that, and then it basically looks at the amount of memory allocated for this particular query as far as memory grant is concerned, and then it basically self tunes itself. So now if you look at this one, what I'm seeing is like the memory grant is not 200 or 155 MB anymore, it is 569 MB. So a SQL Server resolves the issue automatically. Like when we ran it for the first time, it spilled, and it was able to understand like the query spilled because the amount of memory, the memory grant allocated was less, and it was able to tune it and then allocate more memory, and that way we were able to make sure like sort is not spilling to 10 dB. What we'll do now is like let's free up the plan cache. Again, this is a lab machine, so I'm doing this. But on production, we shouldn't be doing that. Even if we need to free up the plan cache, if it is going to be 2 or 3 queries, then we will have to get the plan handle and do it just for those queries, not the whole of plan cache. So right now I have cleaned up the plan cache. Let's execute this query one more time. Now, if you see that, if you look at the execution plan, you can see that the sort is basically spilled to 10 dB. So the first time when it runs, so the first time when the plan is not on the plan cache, so what happens is like SQL Server, in case if it couldn't allocate required memory, it would spill. But the next time you execute this query, what happens is like it looks at the plan cache and looks at this particular query. While picking it up, it understands like there is an issue as far as memory grant is concerned, and then it basically increases the memory grant. And if you look at it, so this time, the second time you execute it, the sort is not spilling to 10 dB. So it is like when you have queries like this, first time the query might take some time because sort and other things might spill to 10 dB. But the second time when you run the same query, what happens is like it reuses the plan and understands the problem, and then it corrects it out. That's it for this video. Thanks for watching. Have a great day. Jai Hind.